Hello world, it's Siraj, and our task today is going to be to try to predict if a team is going to win a game or not. Now this is for football, or as Americans call it, soccer, which is the most popular game globally when it comes to sports. And of all the domestic teams out there, the English Premier League is the most popular of all of them. So we're going to predict the outcome for an English Premier League team using a data set of past games. And this data set, I'll show it to you right now, has a bunch of different statistics. This is what the data set looks like right here. You've got a home team and you've got an away team right here. So it could be Arsenal, it could be Chelsea, Brighton, Manchester City. So you've got a home team and you've got an away team. And then you've got a bunch of statistics. So these are all acronyms, but I have definitions for all of these acronyms that we can look at right over here. Right, so we have acronyms for the full-time home team goals, the home team, the away team, the shots, the target, the corners, the amount of yellow cards, the amount of red cards. So there's a lot of different statistics here, right? There's so many things that go into what makes a team win or lose, right? And so we're going to take all of these features and then we're going to use them to try to predict the target or the label. And the label in our case is going to be the FTR, which is the full-time result. So the FTR is right here, right? H-A-H-D, right? So it could be either the home team, H, the away team, A, or a draw, D. So it's a multi-class classification problem. This is not a binary classification problem. It's not just the home team wins or loses. It's multi-class because there are three possible labels: home team, away team, or draw. So that's what we're going to try to predict given all of those features in the data set. Before I show you the steps, let me just demo this really quickly. So I can just say X test and then just take the first row from this and the labels are gone. This is just for all the features given no label, and we can see that it says home, right? So it's able to predict, given all of those other features, whether or not a team is going to win, lose, or tie the game. Okay, so back up to this. We're going to try to predict the winning football team. And our steps are going to be it's a 4-step process. So our steps are going to be to first clean our data set, make sure that we only use features that we need. What do I mean by that? When it comes to predicting who's going to win a team, there's an entire industry around this, right? There are pre-game analyses by commentators or post-game analyses by commentators. Entire channels like ESPN are dedicated to trying to predict who's going to win a match. And in fact, even during the game, there are commentators trying to predict who's going to win, like during halftime, who's going to win the full game. So this is something that's been going on for forever, right? Since gladiator Roman days or whatever. It's been going on, right? People are trying to predict who's going to win a match. But we're going to do something that people don't do often, and that is using statistical analysis, or otherwise known as machine learning, mathematical optimization, to try to predict who's going to win. If you think about it, this is like one of the most perfect machine learning problems out there, trying to predict who's going to win. Think of all the features out there, and those features don't necessarily have to do with the game. They could be the sentiment of the audience, the sentiment of the crowd, of news articles. How are people talking about a team? What hashtags related to the team are trending on Twitter? Are they home? Are they away? What's the weather like that day? What are the forecast predictions? So there's so many different data points that could go into potentially from across the web telling us whether or not a team is going to win or lose. But since I've never talked about this topic before, I'm just going to start off from a very basic level, and based on your feedback and how you feel about this topic, I can talk about it more and do more advanced things later. Okay, so we're going to clean our data set, then we're going to split it into a training and a testing set. And what I mean by that is we're going to use scikit-learn to do that. I have yet to find a better library for splitting training and testing data than scikit-learn. It is still like the best out there. Even if I'm using TensorFlow or PyTorch to build my model, I'll still use scikit-learn to split my training and testing data. It's just a one-liner, super simple. And then once we split it, we're going to train it on 3 different classifiers. So remember, this is a classification problem, a multi-class classification problem. And so we're going to use either logistic regression, a support vector machine, or, and I've talked about both of those in my Math of Intelligence series, links to those in the description, but I'll also talk about them a little bit in this video, just as a refresher. And the third one is a model that I haven't talked about before, and that's called XGBoost. Well, you could think of it as a technique model, same thing. So we're going to use those 3 as our classifiers. We're going to train all 3 of them on the data set. And then we're going to pick the classifier that has the best result, and that is going to be the classifier that we use to predict the winning team. And we're also going to optimize its hyperparameters using grid search, right? So we're using an ensemble of machine learning methods, which scikit-learn makes very easy to do. Once we pick the right one, then we'll optimize that model, and then we'll take that optimized model and use that to predict the winning team. And so the history of this is, like I said, it's been going on for a long time, and sports betting has just been increasing in popularity for many years, right? If you look at the past 5 years, it's growing at double-digit rates. And there's a lot of reasons for this. Number one is just the accessibility of the internet, right? More people have internet access, and betting on the internet is easier than in person. Another reason is just that machine learning is becoming democratized, and so everybody's being able to build these predictive models to try to predict these scores. So this is definitely a field that's increasing in popularity, and this is not something that's happening in the fringe of society. This is a very mainstream task. Kaggle, the data science community, hosts this yearly competition called March Madness, or Machine Learning Mania, whatever you want to call it, to try to predict the scores for the NCAA, that is basketball. And you have an entire community around this, and people are trying out different models and discussing them, so definitely check that link out as well. So this is something that's happening, and I also found several papers talking about this. So it's not just something that people who want to make money do. This is something that legitimate researchers at academic institutions look into and try to predict, right? So from this paper, I'm quoting verbatim, "It is possible to predict the winner of English County 2020 cricket games in almost 2/3 of instances," right? And then for this other paper right here, something that becomes clear from the results is that Twitter contains enough information to be useful for predicting outcomes for the Premier League. That's for Twitter, right? Right here. So they use Twitter sentiment to try to predict, just Twitter alone, to try to predict who's going to win. So there's a lot of different angles we can look at here, right? We could use sentiment analysis, we could use the past score history, we could use a whole bunch of different things. We're going to use the score history, but you could try to simulate the game in a simulation, and then try to see from that. But there's a lot of different possibilities here. And check this out. In 2014, Bing, which is owned by Microsoft, correctly predicted the outcomes for all the 15 games in the knockout round for the 2014 World Cup. Every single game, 15 of them, 100% accuracy. So you can be sure that Bing's model is really good. However, they are not going to share it with us, because it's kind of like financial analysts at JP Morgan or Chase. If they know how to predict these stock prices, they're not going to tell us. Why would they share their profits with us? So what we've got to do is we've got to figure it out for ourselves to try to reverse engineer the techniques so that we can benefit from it. Okay, so that was a little primer on the background. So back to the data set. So this data set that I got is from footballdata.co.uk. You can find it right here if you go to /data.php. And then what I did was I selected the England football results. And luckily for us, they've got data sets for every season back like 2 decades. So it's perfect. And if you want one, you could just click on Premier League and boom, it downloads just like that. And I showed you the data set. So one thing right off the bat that we can notice is that if we were to just graph, and I've already done this beforehand for us, and it's in Markdown right here, we'll see that the home team has the majority stake of this graph. So that means right off the bat, without doing any machine learning, we already know that if you are a home team, you have an advantage to win. Probabilistically speaking, if you're the home team, you're more likely to win than if you're not, just from that alone. And we can reason about this a couple ways. We could say, well, if you're the home team, then football is a team sport, and the cheering crowd helps you, and you don't need to travel, so you're less fatigued. You're familiar with the pitch and the weather conditions. All these things. You had a hot dog from the stand, and it tastes really good. Just kidding. Baseball food or any kind of sports or like stadium food is never good, you know what I'm saying? I've got 2 great repositories for us. I'm about to start the code here, but I've got one for another EPL prediction, great IPython notebook or Jupyter notebook, and I've got one for that Kaggle competition that I just talked about for NCAA prediction. Definitely check them both out. And this guy, Adesh Pandey, has really great tutorials and software on his GitHub, so just check out all of his repositories, because he has some really great example code. So what we're going to do is I'm just going to code out a good part of this just from the start, and then we're going to just go over the rest. Okay, so don't save. All right, move, 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 move. Okay. So first things first. So our dependencies in this case are going to be to import pandas for data pre-processing. We want to import pandas because that's like the most popular data processing library. And we also talked about XGBoost, right? That is one of the other machine learning models that we want to use, which is going to form a prediction model based on an ensemble of decision trees, which I've talked about as well, decision trees. And so another thing we're going to do is we're going to import logistic regression, right? That's model 2 of 3. There are 3 different models that we're going to train our data set on. One of them is XGBoost, the other is logistic regression, which is used whenever the response variable is categorical, right? Either yes or no, or some kind of non-continuous discrete value, black, white, red, green, things like that. So, which is perfect for us, win, lose, or draw. So we have logistic regression, and then we have one more, which is going to be the support vector machine, right? Support vector machines, I'll talk about that as well. And then finally, we're going to want to import this display library because we are going to display our results. Okay, so that's it for our dependencies, and now we can read our data set. So now we're going to go ahead and look at pandas, and pandas is going to let us read from our CSV file that we downloaded that I've called finaldataset.csv. And then once we have that, we're going to preview that data. So I'm going to say, okay, just go ahead and display the data that I've just pulled into memory as a pandas data frame object. I'll look at its head. That is just the first few columns of that data set. And once I have that, I can go ahead and print it. And now we can see this data set, what it looks like. And so notice there's a whole bunch of acronyms here. Lots of data sets have acronyms like this, and they can be confusing. But like I said, I've got this legend of what each acronym means. The home team goal difference, the difference in points, the difference in last year's prediction for the past 3 games, the wins for the past 3 games for the home team, the number of wins for the past 3 games for the away team. So, I've kind of aggregated this data and I've just made it into something a little more consumable. And so still, remember that we still have one single target that we're trying to predict, and that is FTR, right? The full-time result. For the full-time game, who is the team that won? The home team, the away team, or was it a draw? And so that's our target that we're trying to predict. So before we get into building this model, let's first explore this data set. So if we were to explore this data set, we could say, okay, so first of all, let's just kind of think about what is the win rate for the home team. So what is the win rate for the home team? So how often does the home team win? Aside from anything else, this is kind of what we just talked about, right? How do we do this programmatically? Well, we say, okay, get the total number of matches, and that's going to be that first index in the data frame object, and then calculate the number of features from it. So we want the number of features, and we'll subtract 1 because one of them is going to be the label. That's not going to be our feature, right? The FTR. So we'll subtract 1 from that, and then we're going to calculate the matches won by the home team, which is going to be the length of the data, all right, .ftr, okay, and for the home team. So that's the number of matches that were won by the home team. And finally, we'll calculate the win rate for the home team as well. And then once we have that, finally we can print out the results, and it's going to tell us exactly how many times the home team has won as a percentage of all the wins. So I can go ahead and print that. I've got this print statement right here, and then we can go ahead and see the result. Okay, so already this is the graph that I showed at the beginning. 46%, about 46% of wins are from the team that is home. Just right off the bat, just something for us to know, right? We're exploring the data. We're trying to think about what are the features that matter the most, right? Feature selection, that's the process that we're going through. So remember, when it comes to deep learning, we don't have to really think about what are the ideal features. Deep learning learns those features for us. However, that's like a next step. We're just going to try to build some more basic models first, and then whether or not, based on feedback of how you guys like this topic, I might do a deep learning video on sports analytics later. But right now, we're just going to build these 3 simple models. And thinking about feature selection is a really important skill to have as a data scientist. So right, with deep learning, you don't have to do that. But again, you've got to have a lot of GPUs, and crucially, you have to have a lot of data, right? You have to have a lot of data to be able to do that. Now, in this case, we don't have that much data. We have, in this data set, it downloaded in like, 2 seconds, of course. It was only 500, it's only about 500 data points, right? We want huge amounts of data, at least 100,000. Now, if we had at least 100,000 data points, then this would be something to use deep learning for, right? If we're trying to aggregate a bunch of different results, sentiment from Twitter, past team scores, different, talking points from other people, then we would use something like deep learning. But in this case, we want to try to visualize the distribution of this data. So what we'll do is we'll say, okay, so from pandas, there's this great tool that lets us compute what's called the scatter matrix. And the scatter matrix basically shows how much one variable affects the other. So we're going to build a scatter matrix for a set of our features to try to predict, to try to see just visually what is the correlation between these different features, and see just for ourselves, this will help us pick the relevant features that we want to use, right? So we have the home team goal difference, we have the away team goal difference, we have the home team points, the away team points, the difference in points, and then the difference in last year's prediction. Okay, and so once we visualize this, some of them have a positive correlation, the line is going up. Some of them have a negative correlation. So that means that means if the goals increase for the home team, then maybe the points decrease for the away team, right? And so we can look at the positive versus negative correlations as an indicator of how features are related together, right? This doesn't have some direct relation to what we're about to do, but it's just good practice to think about ways of visualizing our data, seeing the relationship between different features, and then trying to predict what those best features are for our model. Okay, so then once we've explored our data, we're going to prepare it. So remember, we have one single target variable, one single objective or label, as we like to call it, and that is the FTR, the full-time result. So what we want to do is say, given all of those other features, try to predict the FTR, okay, and make us some money. Yeah, no, I'm just kidding. I mean, yes, actually, you probably want to make some money. We're trying to predict the full-time result, right? And so we're going to split it into the FTR and then everything else. Then we'll standardize it, which means it's all going to be on the same scale. That means we want all of our data to be in integer format, and we want it all to be on the same scale. So it's not like we have like one feature is in the hundreds of thousands and then the other feature is in the, between 1 and 10. If they're going to be small values, we want them all to be small values. And what this does is it improves our prediction capability of our model. So once we've standardized our data, then we're going to add these 3 features, which is the last 3 wins for both sides. And we looked at that before, right? HM1, 2, 3, and then AM1, 2, and 3. So if we look back at the data, some of the data was categorical. Like if we look at this data set, we have the referee, we have HTR. We don't want any of that, right? We want all of our data to be either a number. We want it to be some continuous variable, no discrete numbers. So we're going to pre-process those features by saying create a new data frame, find those feature columns that are categorical by saying if the data type is equal to object instead of an integer, and then convert it into an integer, right? So that way we remove all the categorical features. We only have one categorical variable, and that is our label, the FTR. We don't want our features to be categorical. Those are going to be continuous variables. And so once we have that, we've pre-processed our data, we've explored it, we've added the features that we thought were most relevant, and we could see them all here, right? No more categorical features, they're all numbers. And so once we have that, now we can train and we can split our model into a training and a testing data set with a very easy one-liner with scikit-learn, right? And this is going to split with the train test split function, it's going to split that CSV, it's going to split that data frame object into a training and a testing set. And it already knows what the label is going to be, and it's going to put them all in a one-dimensional array, all of those labels, the FTR scores for each of the associated inputs. And we have 12 features, right? We have 12 features for a single input. And so for the next step, now we're going to actually build this model. So I'm going to come back to these helper functions that are going to help us train the model. But let's right now just build this model, right? So I'll go down here. So let's just write this out right now, okay? So I'm going to say, okay, so we know that the first model that we want to try out, or at least one of the models that we want to try out, is logistic regression. I'll give it some random state as a seed that, this could be any number of things, right? Well, I'm just gonna say, 40, I could say 42, it doesn't matter, but just some seed number, and we could try out different seeds to see how the results vary, but I'm just gonna, put some magic numbers down right now to get some result out. And so the next classifier we're gonna build is a support vector machine. So the order of classifiers as I initialize them doesn't really matter, so that's irrelevant, but the fact that I am initializing them is important because it means that these are the 3 important ones that we are using. And so my third classifier is going to be XGBoost. Now, I'm going to talk about what all of these are in a second, but let me just write them out here. We have an XGBoost classifier, and then we have a seed. It's going to be 82. Let me print that. Boom, boom, for A, B, and C. Okay, right? And so if we train this, we'll see that clearly the XGBoost library did the best. So we already know that XGBoost is the best model for this data. And notice that the XGBoost model had an accuracy score and an F1 score of about 74%. That is a 74% accuracy on the testing data set, which is a really good, it's really good. It's better than just guessing, right? It's way better than just trying to guess what team is gonna win. That's about a 75% accuracy. It's pretty good. So let's go back and see what these models are, by the way. So these models, so logistic regression. Now remember, I have a video on logistic regression and I have a video on support vector machines. Just search both of those on YouTube and then the word Siraj. It'll be the first link that shows up. But for logistic regression, it's used to predict the probability of an occurrence of an event by fitting data to a logistic curve. So a logistic curve consists of this equation right here, the probability, right? So if you have 2 classes, if it's a binary classification problem, whether or not someone is dead or alive, the x-axis would be the concentration of the toxin, whether you're trying to predict if someone's going to live or die based on this toxin, and the y-axis is going to be the probability of each of those classes. And we use a logistic regression curve denoted by this equation where you just plug in the x value and it will output a probability to show that. Now in the multi-class case, as is our problem, we're going to use multinomial logistic regression, which the library does for us. But that's what logistic regression does. It's used extensively across a wide range of fields, and it's a very, very popular model. That's going to be our first, and these are all classification models, by the way. Remember, once we frame our problem, then we can pick what model we want to use. We know that this is a classification problem, therefore we want to use a model that is well suited for classification. And then the next question is, based on our data, which of the models is best to use? And we don't always know that right off the bat. Even very experienced data scientists don't always know that. So they have to try out several models to see which one works best. And then for support vector machines, so what a support vector machine does is it will find, so let's say we have 2 classes and we plot them in 2-dimensional space, just like in this image right here. What it will do is it will try to find the points that are closest to each other, to find the smallest margin between both classes. And once it finds these points, these support vectors, it will build a hyperplane right in the middle so that the distance between that line and both of those points is the smallest. And the reason it does that is so that once we give it a new data set, a new data point, whatever side of the line it falls on, that's the class it's going to be. That's how we classify it. So in the simple case, for 2 classes, it's just a line and then it just falls, and then the data will fall on one of 2 sides. But in the more complex case, you'll have all 3 classes and then it will draw a line that's kind of curved between them. So it'll just like segment the graph into the 3 different segments. But the idea is still the same. Finding those closest points and finding the line that minimizes the margin. Okay, so that's for support vector machines. And the last one is XGBoost. So we talked about random forests. It's very similar to a random forest. The XGBoost algorithm is one of the most popular algorithms on Kaggle. When it comes to winners, there are a lot of XGBoost is happening. But basically, the classification and regression tree, the decision tree that's used for both classification and regression is a good model. It's not a great model, but it's a good model. It's a very simple model, right? You give it a bunch of features and it's going to slowly build. There's a variety of ways of doing this, but it's going to build a tree where each branch or level in the tree equates to one question, right? So if you're trying to predict whether or not it's going to rain, it'll be like, is the sky cloudy? Yes, no, yes. Okay, did it rain yesterday? Yes, no, yes, okay, then there's a 75% chance it's gonna rain. So that's a decision tree, right? So what XGBoost does, it's a gradient boosting technique. What it will do is it will create a bunch of weak learners. Those are decision trees that are okay, like their predictive capability isn't that good, and it will combine the results of all of them. So it's an ensemble method. It will take all these trees and then find a result by using the prediction capability of all of those trees. So that's for XGBoost, and we have this tree right here where we have input, age, gender, occupation, a bunch of different features, and we're trying to answer the question, does this person like computer games? Different trees will specialize in answering different parts of the question, like does this person use the computer daily? What's their age? What's their gender? And then we'll combine the results from all of them, so the function of this kid is the result of these two trees predictions combined. So that's what each of those are. And then if we go up here back to these helper methods that I was going to talk about. By the way, the F1 score is just a measure of a model's accuracy. It's a very standard score that just measures how accurate a model is. So back to these three helper methods, what we did here was we gave the train predict function our classifier as well as the training and testing data sets. So if we go back up here, we'll see that in the train predict method, we indicated the classifier that we're going to use, then we trained it given the training and testing data, we predicted the results, and then we predicted the labels. And so this train predict method used the train classifier method to start a clock, fit the model, and then print the results. And then for the labels, it started a clock, made a prediction, and then stopped the clock. So that was it. It just predicted the labels, and then it fit the classifier. Just that. And so once we did that, we realized that XGBoost gave us the best result, right? So XGBoost is the model that we want to use, a 74% accuracy. But that's not enough, right? Now that we know that XGBoost is the best model, now we can say, okay, let's optimize this model. And there are different ways that we could optimize this model, right? But in our case, we're going to optimize it by optimizing the hyperparameters. So this is hyperparameter optimization. There are a bunch of different hyperparameters that go into XGBoost. So we were kind of shielded from that because we use the scikit-learn library. But we can use scikit-learn, ironically enough, to optimize hyperparameters that we don't even normally see. So if we come down here, we can import grid search, which is basically brute forcing. That's what grid search is. We're brute forcing all the possible combinations of all the hyperparameters. We'll create an initial set of hyperparameters here. We'll initialize the XGBoost classifier, and we'll make an F1 scoring function and then perform grid search on that classifier with the scoring function given the initial parameters that we just defined up here. And then it's going to find the ideal parameters for that model, and notice that the F1 score and the accuracy score increased. Right? So after we optimize the hyperparameters, the F1 score and the accuracy score increased, which means that our model is now way more optimized. Anyway, disclaimer, you could make money using this, you could lose money using this. Who knows, right? This is an educated guess. This is a statistical guess based on past data sets. But we can definitely improve this model, right? We could bring in more data, more relevant features. We could bring in sentiment analysis. We could add other features. But there's also one more thing that I want to say. So it's able to predict whether or not the home team will win, right? But based on a data point from this CSV file. However, we don't always know what all of these things are. How are we supposed to predict whether or not there's going to be, X number of fouls? How are we supposed to know whether or not there's going to be X number of offsides? We don't necessarily know these things beforehand, these features beforehand. So the trick is to pick features that are completely predictable. What do I mean by that? That means that what are features that are going to help predict who's going to win, but those features themselves are predictable, like how many players are going to be on the team? Well, you know for a fact there are going to be 5 players on the team. Who are the players going to be? What is the lineup? When is the game happening? Where is the court? Right? So things that you know for sure. And so if all of your features are known, they're all predictable, then your result will not require you to guess what those features are, which is the case in this very basic example. Another way to improve the model is to just use way more quality data. We could also just predict each of these features themselves. Like we could try to predict how many goals are going to occur in a game. We could try to predict all these things and then just have probabilistic values for all of these features and then try to predict the home team, right? So there's a lot of machine learning that could be happening. But ideally, we know for sure what all these features are going to be. and we can use them to then predict the winning team. So if you're interested in this topic, definitely check out all the links in the description and let me know what you guys thought of this topic in the comments. Please subscribe for more programming videos, and for now, I've got to play some football, so thanks for watching.